Well, hello. Okay, before we start what lesson are we on in this class? Lesson 19. I want to point something out to you. So I'm using this blank screen right here. If you go back to page 62 and you look at a problem, like for instance, number 6. I don't know if you noticed this, but the problem goes like this. And you all solve this, and you divided by the negative, and of course because you divided by a negative, dividing by a negative, you all switched the inequality sign to be a greater than or equal to. You did your math, of course, like this, times 10 over 10, kind of sloppy here, but you did a much better job. And you figured out that your answer over here was negative 6, and then your answer over here, of course, was the x. My purpose of going over this problem is that this is kind of sort of in the wrong order. Look at it. It has the number first and the variable second. When you have an inequality and the variable is not first, you want the variable to be first. You want the variable to be first. Think about that. You want the variable to be first. So you're comparing the variable to negative 6. And what you have to know is that the inequality sign is eating the negative 6. So when you write the inequality sign, it still needs to be eating the negative 6. This right here is the inequality that you want to look at. So you need to be able to exchange negative 6 is greater than or equal to x for x is less than or equal to negative 6. So stop this video, rewatch it, and make sure that you understand that you want the x to be first. Look at it. The mouth is eating the negative 6. It's still eating the negative 6. You want to rearrange it so that the x is first. This is going to help you when you're doing a lot of graphing, because its x is less than or equal to negative 6. So you have your negative 6, you have your negative 5, you have your negative 7. You know that there's a solid dot there, and these are all the numbers that are smaller. When the x is not first, it's more confusing. This is more confusing, and it's not the right way that we want to write it. We always want to flip it, but we flip the x first, but we look at the mouth. The mouth still has to be eating the same number as in the problem. All right. If you need to watch that first part again, definitely watch that first part again. All right, let me erase this. Sometimes it takes me 2 or 3 times. I'm not sure why it doesn't like to erase all at once, but new technology, that's the way it goes. Okay, so let's go now up to page 63. On page 63, you see your warm-up, and the whole page actually is your warm-up until we get down to the aim. So go ahead and turn off your video. Go ahead and do your warm-up, including the inequality applications. The inequality applications, let me just get you started on that. What you're going to do is you're going to take, for instance, the word maximum, and you're going to put maximum in the right place. Greater than or equal to, would that mean the maximum? Would it mean greater than mean the maximum? Would less than or equal to be the maximum, or less than be the maximum? Actually, change my mind. This is what I want you to do instead. I want you to just do the first 3 problems and then turn the video back on. That's enough for right now. So just do 1, 2, and 3, and I'll see you back here in a few minutes. Turn off the video, do the warm-up, turn it back on. Okay, welcome back. Hopefully everyone says yes. And how do we know? Because it's a straight line. And, yep, it goes through the origin. Any graph that's a straight line that goes through the origin, you know that that's going to be a proportional relationship. That's wording that you should know. All right. Next one is an interest problem, and so you're going to earn 4% of that $300. That's your principal, that's your rate, and then you're going to continue doing that for 6 years. And yes, Alex, this is not how it really is done. This is simple interest, and I appreciate every time that you've asked me that question, and eventually that's going to change for you, just not right now. If you want to, you can use a calculator or you can just use your brain, either way. But when you get your answer, you should have $72 in interest. Hopefully everyone's really good at solving this equation. Hopefully we use distributive property. Some of you will write that we have 4 times 2x minus 4 times 6. Some of you will go directly to 8x minus 24 is equal to negative 9. Everybody will continue solving that. And thought I did something wrong there for a minute. And we get an answer of 15/8. And we do not need to change that to a mixed number because we're in 7th grade now and it's already simplified. All right. Now, I'd like to go down to this inequality applications and I want to give you more direction. So I want you to think about these words, and you can start anywhere you want. Let's say that, let's start with down here. Let's say with at a minimum. So let's say that you're running a restaurant and it says at a minimum there has to be 15 people there for you to open the doors. So at a minimum. So does that mean it's greater than or equal to 15 people? Greater than 15 people? Less than or equal to 15 people? Or less than 15 people? If there's at a minimum, 15 people before you're going to open the doors, then that means 15 people is fine. And at a minimum of 15 people, it means that you want more than 15 people. If there's 14 people, you're not going to open the door. At a minimum of 15 people, that means you would be happy with 15 people, 16 people, 17 people, 18 people. So at a minimum goes here. I didn't spell that right. Look at it again. Fix it. Let's do one that's easy. Everybody, whoops, let me change the color. Everybody do less than or equal to. Put that in the correct column. Less than or equal to. Everyone put it over here. All right. Let's do another one. Let's do below. If it's going to be below 30 degrees, whoops. If it's below 30 degrees, could the temperature equal 30 degrees? Nope. It has to be less than 30 degrees. So below would be over here. Think about it. Let's do at most. Let's say at most it can be 30 degrees. So if it's at most 30 degrees, are we okay with it if it is 30 degrees? Yep. At most 30 degrees. Does that mean it's okay if it's 31 degrees or if it's 29 degrees? Maybe you're making, you're storing ice cream, and at most it can be 30 degrees and then it starts melting. So at most means that it needs to be less than or equal to 30 degrees. So at most means less than or equal to. All right. Now I want you to go through and do all the rest of these. So turn off your video, put all the rest of these phrases or words in the correct column, and then come back and I'm going to do them and let's see how if we're the same. So turn off your video and then come back. Okay. I'm going to do maximum. Let's say that the maximum number of people in a room, well, right now it's 10. So if the maximum number of people in the room is 10, can we have 10 people? Yep. If the maximum number of people allowed is 10, can we have 11 or do we have to have 9? We have to have 9, so it's less than or equal to. So less than or equal to is where we put maximum. Let's try another one. I'm going to cross them out as we do them. Let's do smaller than. If you have to be smaller than 32 inches to go on a ride, can you be 32 inches? You have to be smaller than 32 inches. Nope, you can't be 32 inches. You have to be smaller than 32 inches. So can you be 33 inches or 31 inches? 31 inches is right, so it's less than. Under less than, we put smaller than. All right. Larger than. Let's say that you have to be larger than 4 feet to go on a ride. If you have to be larger than 4 feet, are they going to let you be there if you're 4 feet? Nope. So no equal sign. Will they let you be there for your 5 feet or 3 feet? Larger than has to be greater than 4. Larger than. All right. Not more than. Let me choose a different color here. Not more than. Let's say that to pay the child's price, you can be not more than 12 years old. Not more than 12 years old. Think about it. Can you be 12 years old? Yep. Not more than 12 years old is 12 years old. So there's an equal sign. And if you're not more than 12 years old, think, can you be 13 or can you be 11? If you're not more than 12, that means you're 11, so it's less than or equal to. Not more than. All right, next one. Less than or equal to. That one's pretty easy. Less than or equal to is exactly like that. Oh, we already did that one. All right. Not greater than. Let's do not greater than. Let's say that you can't not greater than, let's say that you're going, I don't know, on a ride, and you can weigh not greater than 60 pounds. If you can't be greater than 60 pounds, can you be 60 pounds? Not greater than 60 pounds? Yes, you can be 60. And then think, can you be 61 pounds or 59 pounds? If you're not greater than 60 pounds, it's less than or equal to. So this is not greater than. All right. Not less than. So let's say that you have to stay in the house not less than 15 days. Not less than 15 days. Think about it for a minute. Not less than. Can you stay in the house for 15 days in your quarantine? Not less than 15 days? Yep. And then, can you stay in for 16 days or 14 days? Not less than 15 days means that you're going to have to be there at least 15 days. So it's greater than or equal to. All right, getting down to it. Let's do easy ones next. Greater than. Greater than. Less than. Less than. We don't have to think so much here. All right, let's go to the thinking ones again. At least. If you have to be in isolation for at least 15 days, does that mean you can be in isolation for 15 days? At least 15 days. Yep. And then, is it greater or less than? If at least 15 days, that means 16 days, 17 days, so it's greater than or equal to 15. So this right here is at least. It's not that easy, you guys. Greater than or equal to, let's do something more cheery. Let's say that greater than or equal to, you're playing the lottery, and you're going to earn an amount that is greater than or equal to $1 million. Greater than or equal to, could it be $1 million? Yep. And then greater than or equal to $1 million. $1,001, $2 million, $15 million, something like that. Greater than or equal to. And then we're left with more than. We'll go to more than. More than 50 people are in the room. So there's more than 50 people. That means there's not 50 people. There's greater than 50 people. All right, so let's check them off. Over here for greater than or equal to, we should have not less than, yep, at least, at a minimum, greater than or equal to. Yay, we have them all. All right, over here for greater than, we have larger than, more than, greater than. Yay, we're in agreement. Let's try the next one. For less than or equal to, I have maximum, at most, not more than, less than or equal to, not greater than. Phew, we're doing pretty well. All right, for less than, we have less than, we have smaller than, and we have below. So it looks like we did a good job. This is not easy. You might want to start this again and make sure that you understand it. All right. Now we finally get to write our aim. Our aim, if you look at the next page, is now we have word problems. So what we're going to be doing in this lesson is we're going to set up and solve inequalities for real world problems. Set up and solve. Now we've set up and solved equations, but now we're on to inequalities. So set up and solve inequalities for real world problems. All right, here we go. Your weekly base salary is $150. You earn $20 for each cell phone that you sell. Write and solve an inequality that represents the number of cell phones that you must sell to make at least $630 a week. So, as always, we start with what are they asking? They want to know the number of cell phones that we must sell. So, we choose a variable. I'm going to choose C, and C is going to be the number of cell phones that we're going to sell. So, everybody defines their variable. Now, it's much like setting up an equation, so use what you know about setting up an equations. So we get $150 no matter what we do, plus we earn $20 over and over again for each cell phone that we sell. And then we need to get at least $630. So we ask ourselves, if we want at least $630, are we going to be happy with $630? If we want at least $630, yep, we're happy. So there's an equal sign. Then, if we want at least $630, do we want more than $630 or less than $630? At least $630 means we want more than $630. There's our inequality. From there, no problem. You all solve it at your own rate. Remember, if I'm going fast, too fast, you just stop this and then you go ahead and restart it when you're ready for it. We subtracted. Inequality sign stays the same. We divided by a positive number. Inequality sign stays the same. It's a word problem, so we need a word answer. How many cell phones must you sell? You must sell at least, or some words that mean this, at least 24 cell phones. You can say something like, you must sell 24 cell phones or more. You must sell greater than or equal to 24 cell phones. Something that makes sense to you. All right, let's go down to number 2, the Technology Club. The Technology Club is trying to raise $1,000 raffling cornhole boards. That's that new game. They have already made $100, and they're selling raffle tickets for $5 each. How many more must they sell? That's the question, to make at least $1,000. So, what do they want to know? They want to know the number of tickets. We define the variable first. I'm going to use T. You can put the number of raffle tickets if you'd like. All right, so let's see what's happening. They want to raise $1,000. They're trying to raise $1,000. So they've already made $100. So they have $100 sitting there in their bank account or in their hand. And then that amount's going to increase by every ticket that they sell. And they're going to increase by $5 every time they sell a ticket. And they want to make at least $1,000. So to make at least, you need to think about this for a minute, to make at least $1,000. Are they happy with $1,000? The answer is yes. Do they want to make more than $1,000 or less than $1,000? To make at least $1,000, they want to make more than $1,000. There's your equation. Okay, go ahead and solve it at your own pace. Turn back on your video and see if I made any mistakes. See if you agree with me. We subtracted 100. The inequality sign stays the same. We divided by a positive number. The inequality sign stays the same. We answer the question. How many tickets do they need to sell? They need to sell 180 or more tickets. You do not need to use my exact same words. Maybe you want to say that they need to sell at least 180 more tickets. They need to sell, more than, you can use anything on that other list. All right. We're going to try 2 more for today, and that's it. So let's go over here to number 3. Go ahead of me. You can turn off the video, go ahead of me, then come back and watch it. They receive $300 per month from each residential site that is occupied, as well as $2,000 from their overnight sites. So some people live there, and so when they live there, they're getting $300 a month. And then the people that come just to camp for one night, they make a total of $2,000 doing that. Write and solve an inequality to find the number of residential sites that must be occupied to make at least 14,000. There's that at least again. They like that in these problems right here. All right, so what is it that we're trying to find? We're trying to find the number of residential sites. How many people live there? So the number of residential sites, of occupied residential sites. You might not be so have so many words as me. All right. So for each residential site that someone lives in, they're making $300. So $300 times every residential site that's occupied. Plus, they make $2,000 from the people that just come for one night. And they want to make at least $14,000. So if they want to make at least $14,000, the first question is, are they okay with $14,000? And the answer is yes. And then if they want to make at least $14,000, do they want to make more than $14,000 or less than $14,000? Yep, that's right. There's your equation. Look at it. Make sure that's what you have. Solve it. Again, at your pace. Think to yourself, we just subtracted, so the inequality sign does not change. And then we divide. We're dividing by a positive number, so the inequality sign again. Whoops, again, erase that. Ooh, it's still erasing. Hold on. There we go. The inequality sign does not change direction. And then we answer the question. The number of residential sites that must be occupied. So you can say 40 or more, at least 40. We're writing complete sentences because it's a word problem. All right, last one we're going to do today. So hang in there. I'd really like you to go ahead of me. I'd really like you to try this without my guidance. So read it and then come back, turn back on the video, and see how you do. All right, here we go. Has a fixed weekly expense of $750. Each animal in the shelter costs an additional $6 a week. During the winter months, the weekly expenses are at most $900. And so write and solve the inequality that represents the number of animals the shelter for the number of animals at the shelter for expenses to be at most $900. So they've changed it now. At most $900. So let's see what's happening. Every week, they spend $750, probably on electricity and maybe the people that work for them, that kind of thing. For weekly expenses, that's a fixed weekly expense of $750. Plus an additional $6 each week. And the $6 a week for each animal. So I'm going to use A. A is equal to the number of animals. So if there's one animal, we do $6 times 1. If there's 10 animals, we do $6 times 10. If there's 100 animals, we do $6 times 100. Well, we have A animals, so we do $6 times each animal that's in the shelter. And in the winter, there's at most, all they have to pay is $900. So they must not have that many animals there. So if it's at most $900, at most, you can say at the most, it's $900, so $900 works. And then if the shelter expenses are at most $900, think, does that mean they're $1,000 or $800? Put in your inequality sign. At most 900 means that it's at most 900, so it's less than or equal to 900. Look at your inequality, make sure you have it right, solve it. You subtracted, inequality sign stays the same. Divide. I'm just going to divide each of these in half. Makes my life easier. We divided by a positive number, so the inequality sign stays the same. And then we answer the question. The number of animals that would be there, I'm going to write, it would be 25 animals or less. I'm going to write that there's no more than 25 animals. Maybe you wrote at most there are 25 animals, something like that. All right, writing and solving these inequalities is kind of hard. It's kind of a difficult thing, so we're just taking it slowly. Today we worked on these 4. Tonight, or today after this lesson, the only thing you're going to do is page 65. You're going to do page 65, and then you're going to stop. In order to do page 65, numbers 1 through 6 just requires you to look at the inequality and match it up with the correct graph. So all the numbers are less than 1. So you have to make sure that you look for the hollow dot versus the filled in dot. So this right here is your answer for number 1. So you put the H over here, and then down at the bottom, number 1 becomes H, and so forth and so on. For exercises 7 through 18, you need to make sure that you're solving the equation. If you have enough room to solve the equation right here, you can. Every time you have to think, does the inequality sign stay the same or does it change? And that's all dependent on whether or not you've multiplied or divided by a negative number. I need to see all the work. You need to solve the inequality, and then you need to match it up with the right graph. So n is less than 2, so I need to look where it's less than 2. I know that the 2 is not included, and it's all the numbers that are smaller than 2. So this is I, and I need to see that they're matched up. And then down here, number 7 becomes an I. Now you're welcome to do your work right here on this worksheet. If you don't have enough room, if you feel uncomfortable doing that, obviously do it on another piece of paper, number it page 65, and put it in with your work. Once you finish this page, once you've gotten down to number 18 done, then you can go ahead and stop for the day. Make sure you show all your work. Make sure you come tomorrow with any kind of questions that you might have so that you can look at this and see what's going on. All right, I think that's about it. Have a wonderful day,